All right, so tonight we're going to take a little bit of a detour into VBA, visual-based applications. That's the language that comes with Excel. And so this is the language that we'll be using for the assignments. So let me just introduce it to you. And so you can see how easy it is. Now, I just want to mention that some of the details here might be slightly different on the Mac and PC. I'm using a PC, but I don't think there's differences between the two radical when it comes to VBAs. For certain things, the two systems are different, quite a bit different. But here, I think they'll be very, very similar to each other. So if you are using a Mac, I don't think you'll have any difficulty with this. Anyway, so let's take a look at what VBA is all about. And you can see, you will see that it's very similar, or it's designed to be very English-like. The commands are meant to be very straightforward and user-friendly. And it ties in very nicely with Excel. The only thing we have to watch out for is that the commands in Excel and VBA can be a little bit different. So there's sometimes there can be naming conflicts if we're not careful, but basically you'll see that VBA is designed to be pretty user friendly. Like I said, it's almost like very, let's say, basic version of Python. If you're familiar with it, Python in some ways is very much like VBA, except it's much more powerful because it was invented, I guess, in the 21st century instead of the 20th. But anyway, so why don't we start with the slides, which I recently added to Blackboard. Um, now, we start by noting that as far as Excel is concerned, it has this Visual Basic Editor built into it, but you have to actually install it yourself. So this is where there might be some slight differences between the Mac and the PC. So let me just show you briefly how this would go about. First of all, if you look at this VBA code examples, which we're going to be looking at later on, the tab that you need for this developer. Now, it's been so long since I installed this. I don't remember if the default is to show Visual Basic or not. If not, what you would have to do is go to the options on the PC at least. And one of the options is to update the ribbon, customize ribbon. And so when you do, what you're going to ask it for is you have to click on this little developer button. And if it's not already there, and that'll make it possible to see the VBA editor. Okay, so in other words, it's one, I still don't understand why it's not this way. You've got this ribbon, which has almost everything that they make built into it, except for the developer tab. I'm not quite sure what that's all about. So if you don't see it up there, you have to click on this developer box under main tabs, and then you'll be all set. So in other words, you should see developer over here, you should see Visual Basic. And in this spreadsheet that I posted tonight, I have several examples of VBA code you can follow and use as a template for what we'll need here. And so there's some things we need to become comfortable with. And so first things first. Now this, by the way, this happens to be a picture of what it used to look like in the Mac a while back. I used to actually have a Mac, but I decided to stick with the PC only. So the graphics are slightly different, but you have the same basic choices here. The one you want is editor, and later on we'll see what to do with macros. All right, so now if you notice, okay, here's our first example of actual code. So what we want to notice here is that when you write a program in VBA, there's two basic types of programs that we can create. Actually, let me put this in a Word document real fast. The one you see there is called sub. And so the two basic types of code you can write. Sub stands for subroutine, which is also referred to as a macro. And the other one is actually function, just like an Excel function. In other words, if you write a function, you're going to wind up with um, something that actually an Excel will interpret as a built-in function, as if it came from Excel in the first place. It doesn't, well, at least it doesn't seem to know that you wrote it. Okay. So let's see if I can find an example of one here real fast. So these are mostly subroutines. But oh, there's a huge list here. Hold on a second. There we go. Function. I knew there had to be at least one that was an actual function. Okay. So now, if you notice with VBA, all these blue words, what is that? Okay. So the way it's set up here is that when you write code, the blue commands are keywords, as they're called. These are reserved words that you can only use for specific purposes in VBA. These are built in, cannot be used for any other purpose. And so the blue is just to help remind you when you type something into a VBA program, like sub, it wants to remind you, don't use this for something else. It's a subroutine. You're telling the VBA that this is a subroutine. Now, if you notice, the way this works is that you have the sub, but a header, but you also have to have this end sub command. Now, as it turns out, VBA will provide that for you once it sees that you're using a subroutine. So in other words, as soon as you type the keyword sub, it will fill it in for you at the bottom. You just have to make sure all your code is in between the header and the end sub command. Now, here you notice there's a couple of constants we're defining here. Price of gas is 225, number of gallons is 20. Now, those underlines are there because you can't leave blanks in your names. Okay? These are the names of constants that you're defining. They cannot have blanks, otherwise you'll confuse VBA. Now you can see here, total spent is the price of gas times the number of gallons. So you can see it's intended to be very English-like. And this is a formula that you've created. And so what's happening here is that this is what you're really interested in. You're basically saying, please tell me how much I've spent on gas, given the price of gas is 225 and the number of gallons is 20. Now, the rest of this is just a way of getting that information back to the program. Okay, that's the only reason this information is here. So debug print, it specifies where to put this information. Then we're going to put a title, price of gas, which has to be in quotes. The ampersand tells it that something is coming, and that something is the variable price of gas. And we do the same thing for number of gallons equals, then we have the ampersand and number of gallons. And then finally, the total spent equals and total spent. So what we're going to do now is run this and see how it reacts. Okay, so let's come back here. And how do you run it, by the way? When it's a subroutine like that, what you're going to do is go to this list of macros and look for the one you want. And in this case, it was called gas expenditures. So what you have to do is choose that one. And if you hit run, oh, no wonder, that's right, I forgot. Instead of putting it on the spreadsheet, those debug commands, if you remember debug print, the purpose of that is to put it in a special window. The so-called immediate window where you're looking at results, possibly before the program is finished. And this is where it printed our results. Price of gas is 225, number of gallons is 20, and then finally total spend is 45. If I did not print these out, I could have told it where to print them on the spreadsheet. In fact, that's usually the way we'll do this. I think what I'm going to do is go find another example where we've done exactly that. By the way, they explain here in great detail. There's a bunch of other windows that we can define here where we put information about what's happening as the program is executed. We won't really need a lot of this. We're going to write some very simple programs. The one thing you want to pay attention to is this so-called object browser where it keeps track of all the information that you're creating with your program. But we'll get back to that in a minute. First, what I want to do is show you. Oh, let's see. Let's try to find a program where the results go onto the spreadsheet. How about function counter? All right, well, this is different because this is a function, but the function, let's put this on this spreadsheet, VBA code examples, and look at this command. There's function counter. You notice how in parentheses it says as an integer. That means give me an integer, and I will give you the sum of the first n integers is what we're looking for. And so I'll try it out here. Equals, or remember, Excel at this point thinks that counter is one of the functions built into it. Okay, there it is. Now you notice it's listed there separately as if it was a built-in Excel command. So let's say I'm interested in some of the first 5 integers. And it comes back with 15. Well, there you go. And of course, that's 1, 2, 3, 4, 5 added together. What exactly did it do? Well, first of all, because it's a function, you have to tell it what inputs are needed to run a program. That's what goes in here in parentheses. And ideally, you'd also like to tell it what each variable type is. Here, of course, it's an integer, but all the others are available too. But that part isn't absolutely necessary. It's just, it helps avoid problems to make sure that we're using types that we're expecting. And then now dim sum is integer. Now this is a variable that is being used inside the program. It is not going to be returned to the program when we're done. We won't need it any longer. So think of it as a temporary variable. We always start by setting these variables equal to some constant, usually 0, just to make sure that we know what to expect. And then you'll see as we'll get back into this later on, this is what we call a for loop. It says, all right, well, X is going to run from 1 to n, one at a time. The sum in each case will be incremented by X. And at the end, we'll have our answer. Then you see how it says here, counter equals sum. That means send this result from this loop back to Excel. Okay, because now here's an important detail. This must equal or be spelled exactly the same as the function name. Okay, so this is our first very basic function, and you can see that this is the basic structure for all of them. What will be different is, of course, here the actual code, but the basic logic is always the same. Read information into the function, possibly define some interior or internal variables that we'll need, initialize them, run some operations on them, and return them back to the program. Okay. And also, if you notice here, when we start with function, VBA provides us with this end function command is the program. All right. So yeah, we don't want to have to spend too much time with the structure of the program. This is much more important, the elements of the language. So it has all kinds of elements that we could potentially use. We have variables, constants, procedures, arrays, et cetera, et cetera. So let's take a look at these. So of course, a variable is used to store values that can change within the program. And we can have many different kinds of variables. As you can see, they don't have to be integers. We can have a byte, which is a single unit of information. For example, a byte is formally defined as enough storage to store a single letter, character, or special character. Integer, of course, we know what that means. Long integer means it can have a larger value. So the integer variable is restricted. There's some limitation on how big integer can be. It's listed in this table down here. Yeah, so if you need an integer larger than these numbers, then you'll have to go with long integer. But that, of course, requires more storage. Now, at this point in time, the amount of storage that's involved is laughably small. It's something we don't even have to worry about. But in the early days of Excel in the 70s, this made a big difference. Computers didn't have nearly as much storage as they do now, and storage was horribly expensive. So this was hugely important. It mattered a great deal. You had to think long and hard if you want to use integers or long integers because you're using twice as much storage here. Okay, so yes, those were the days when storage was really, really expensive. Yes. So now it's gotten to the point where an Apple Watch probably has more memory than any mainframe from the 1980s even. I mean, okay. All right. Anyway, let's see. Um, oh, here we go. So these are some of the other ones you have access to. Um, you've got like this one stands for single precision. That means it's not an integer. It can have a fractional component within this range. And if that's still not good enough, and you can see, by the way, these numbers are so large that they require scientific notation to represent them. This is um, times 10 to the 38th power. This means times 10 to the 45th power. If that's still not good enough, we have double negative, double positive, and then currency, which will include a dollar sign. So most likely you'll be using integers or single precision. Yeah, so a byte can hold a single letter, number, or character. We know what an integer is. There's no fractional part, but the regular integer has to be somewhere between negative 32,768 and positive 32,767. Need something bigger. Well, then you can use the long integer. Okay. Single and double precision. We can store a real number within the maximum allowable ranges. And again, the only difference between the two is really the storage. And yes, and sometimes they're expressed in scientific notation. Currency is meant for like accounting data, let's say, where you want to have dollar signs and commas and that type of thing. And there's a few others. You're not going to see these very often. Here's an interesting one. The Boolean is a variable that can either be true or false. And so the way it's set up, just like in Excel, 1 means true and 0 means false. So you might have a variable in your program that says something like retired, yes or no, that kind of thing. So in other words, if the variable refers to whether a person is retired or not, then this would be the ideal choice for that type of variable because either they're retired or they're not. You can't, that it's yes or no. So then we have dates, strings, which means letters or other characters. Some of these others, like variant, means it can be literally anything. It's like an open book variable, which means what will happen is if you leave it at variant, then VBA will figure out for you which one it must be. You might say, well, why don't we always do that? Because that's very wasteful of space. Okay, although again, at this point in time, maybe that's not such a big deal. Boolean is either true or false. Remember, in Excel and in VBA, 1 is true and 0 is false. Then we can have dates, strings, which means we can have letters, but they must be contained within quotes. They can have a fixed length, or they can actually be variable. You can change it inside program if you need it. Objects, all everything inside VBA is an object, okay, at some level. Um, an object could be a workbook, row, column, cell, whatever it is. This was all the rage at that time. This is a so-called object-oriented language. That's what it was called. And it's designed, it's like it's this big structure where you've got the whole workbook and you've got within the workbook, you've got sheets, and within the worksheet, you have cells, and then, it works its way in. It's almost like a big Russian doll, basically. So it's organized this way deliberately because at the time it was felt like this is the most efficient way to keep track of all the components of the program. And so now I'm sure that, you know, computer science has gotten much more sophisticated since then, but this was all this was the state of the art in the 70s and 80s. Okay, so we're gonna still use it this way. This is how eBay's been set up. Set. So, if you use the word set, that means, and you can't just say, for example, ran equals range A1 to C1. We need set to do that. Because it's not like an equation, let's say x equals 3 or something like that. That's okay, but something like this, you need to use the keyword set. There is the one that can be anything. VBA will figure it out for you, but then you'll probably end up using a lot of storage. Then you can create your own user-defined variables in case you need something very specialized, like a record, for example, at a bank, which contains somebody's name, account number, social security number, that kind of thing. Now, who can tell the program what type each variable is? But it turns out VBA is a very forgiving language, which means it's not absolutely necessary if you figure it out for the context. But it makes a lot of people nervous, and they don't like that because then there's a chance that there might be, without realizing it, making an assumption that's not true. So by forcing, like here, for example, this ing, we make sure that we define it as them as integers to make sure that we don't accidentally assign them a number like 3.7. Okay. So yeah, so we can define these variables with these special keywords. Dim means dimension. Basically, the purpose of what we're seeing here is to set aside storage for these variables. Okay. So when you say dim, it means dimension. And let's see, let's go back here. Right. So here's ing. I'm using these as indices. The way the program is set up, if I left this command out, it was still run. Okay. But then we're taking a chance on mistakenly assigning something to ing that we shouldn't have. So it's kind of like a way of protecting yourself from making a mistake. So it's good programming practice to make sure that all these variables have been formally identified with this dim statement. Let's look at another one here. See, here's dim sum is integer. Now that one's important. I do not want integer to be, I'm sorry, I don't want sum to be a real number. It's got to be an integer because of what I need it to do. And here you can see we've got, for these sales tax calculations, I've got tax rate. Remember, that's single precision. It's a real number, but there's a limit to how many digits it can have. Purchase, same thing, sales tax. So if you don't need a ton of digits after the decimal point, single, it works beautifully. Okay. What else we got? String. Here's one. Dim item is string. You don't see that very often, but here we have a string. In fact, it might be fun to run this one just to see what it looks like. Some uppercase. To come back here, and since it's not a function, we're going to run one of the macros, uppercase, and okay, what happened? Oh, it's specifically, it says that you'll find the value in A1. I just realized that. So let's change this to house, something like that. And then I'm going to run this macro here, and it'll be uppercase. And here's what it's going to do. Okay, now just like magic, it turned all the lowercase letters into uppercase letters. Okay, so how did it accomplish this feat? Well, first of all, we had to make sure that it knows that this is a string, not a number. Okay, and then we tell it where to find it. Range a one means go install a one for the value that you need, and then now here's a command offset, which means take wherever you are now and move one column to the right to put your result, and it is uCase. Now, uCase is an actual function built into VBA, which says turn whatever you're looking at into uppercase. Okay. So our program isn't really doing the conversion. We're leaning on an existing VBA command, and we're saying, listen, go look in cell A1, whatever you see there, as long as it's a string, change that to an uppercase. And then, of course, we've seen before, here's sub, which means it's a subroutine or macro, and then it automatically provides this ending statement. Okay, you can notice right now that the blue are the keywords, the black is regular code. While we're talking about the colors, let me just show you quickly that if you want to put a comment in here that the computer won't read, you put an apostrophe, single apostrophe. You can write something like this, converts a string into the uppercase version. As soon as I move down to the next line, it turns into green. Green means this is a comment which is being ignored by the computer. It's there to help you keep track of what you're doing. So when you come back to this code down the road, you won't forget what was going on. It's a great way to especially remind yourself what all these different variables mean and what the intention of the program is. Okay, so that's something, it's up to you to document your programs, but it's a great feature to have available. That it's like writing a little note to yourself. By the way, this represents the sales tax, and this represents the cost of the good, that kind of thing. All right, let's see, what else do we have? Oh, some other examples. Dim customers is integer, dim price is currency, dim length is single, male is Boolean. Now that one, you can see it's either yes or no. And so that's why it's Boolean. Name is string. Of course, it's a string because it's all letters. Birthday is date. And then distance. Now you notice there's nothing here. That will be interpreted by VBA as a variant. That's the one that will depend on the context. So whatever as information you assign to distance, VBA will say, oh, he meant a integer, or no, he meant a real number, and it will figure that out for you, but at the cost of taking up more storage space. All right, let's see. Okay. Oh, and now here's an example of user-defined variable. Imagine yourself again, you work at some company, they're keeping track of their customer information. We're going to define a variable called personal information, and it's basically a record, as it's called, which contains the first name, the last name, which are both strings, the date of birth, which is a date, of course, marital status, here it'll be a string. Although in different contexts, it's quite a full variable, and then and types. So now, if I have this information coming into my program, I have to provide it with a name, first name, last name, a birth date, and marital status. Now, option explicit, sometimes, it can be a little scary, but you can get away with VBA. And so if you want to self-discipline yourself, you can ask for this command, option explicit, which means you must define each variable with this dim command. If you leave one out, it'll stop, right? It won't work. And that way, in case you think you might accidentally do something like that, you can put it in there and say, please tell me if I've forgotten to define a variable. That's what it's essentially doing. So we call it option explicit. Let's see. Here's the sales text. Now, if you notice with the sales text function, let's go back to the program here. Unfortunately, none of these are labeled properly. I just realized they also say VBA example. Oh boy. Oh wait, that's a variation of it. There's our gas expenditures. Let's see. Maybe I don't want to waste all night with this. Well, there is. Oh, but that's okay. This is the earlier version of it. What they're saying here is that if you want to make sure that the right information gets cast into your program, you see what they've done here: function, sales tax, retail prices, single. See, that's not here. Way this is written now, any information can be passed to this function, and anything can come out of it. So if you want to make sure that the retail price and the sales tax are both single precision or real numbers, what you could do is what. And by the way, if you notice, after I type that, it not only changed the color blue, but also with the correct punctuation, in other words, or capitalization, I should say. They're supposed to be capitalized. I didn't. But if you notice, it did that for me. It's watching over my shoulder, basically. Um, Now, wait a minute, what happened there? There we go. There we go. It was waiting for me to finish the line. So in other words, what it's saying is that now if I try to pass I'm sorry, an integer to the retail price or the sales tax, it'll say, whoops, sorry, I can't do that. And then when the function is done, result that comes back to the spreadsheet is a single precision variable. It will not be an integer or a string or something like that. So if I want to run this one, let's see. Oops, no, that's not what equals sales. What do I call it? Sales underscore tax. There it is. Now, at this point, if you notice, I added this just now. So what I'm going to try to do is confuse it by typing a letter and then a real number. See how it reacts to that. Oh, it doesn't like that at all. Okay, I figured as much. So let's change that to retail prices at, let's say, $100. Although I probably can just leave it like that. It'll figure out, it'll assume that this is single precision on the integer. And then the sales tax rate, let's say, is 0.06. And it comes back and says, oh, you mean $6. $100 times 6% is $6. And so it says 6 here, but let me just see something here. It just says, oh, it just says general. Okay. But if I try to use this in another program, it will interpret this as a single precision because of this part here where it said as single. If I don't want that, I can change it to anything I want. But if I don't put this information in there at all, it'll try to figure it out from the context. And that could potentially lead to mistakes. We don't, of course, want mistakes, do we? No. Okay. So, oh, and so if we have constants that need results or values, now you notice here these were declared dim age as integers so that we know that it's an integer. Then when it's time to actually give it the information that it needs, just put the equal sign. The only problem, yeah, or, I'm sorry, the only thing is that the string variables need quotes. But with quotes, you can have blanks. The birthday, now look at this. This is weird. The birthday requires those pound signs. Or now in this day and age, we're called hashtags. And then the distance is can be anything because we didn't specify it. Now, this is one of these quirky things about this language. This symbol actually is being used to represent assignment. Actual equality is represented by double equals. Okay, we'll see that later. Then we could have a constant, and we don't want it to ever change. Let's say, for example, your program requires knowledge of the sales tax rate, and yeah, we can tell it it's simple. But the thing is, in order to make sure that we can't accidentally change it, we can use this keyword const for constant. Okay. So like if I come back here, okay. See, it's not listed here separately, but what it could do is say const. Okay, I don't think this is going to work because I'm passing in the information. Let me do something a little different. Let's have const. Um, what would I put here? Um, the one thing we got to watch out for is the function return one variable. So we all try this with a different example. But if there's a number in there that is not meant to be changed, like, oh, here, perfect examples. Price of gas. If I want to make sure that I can't later on in the program change it, I can put this keyword const, and that means if I try to change the price of gas, it will stop me. Okay. And then possibly the number else is constant as well. Okay, now there are some rules I follow with the names. All names must start with a letter. We can't have any of these special characters, and it can't go past 255 characters. I think we know that. And of course, we do not want to use by mistake any keywords. And yes, either take the form of a function, as we saw already, or subroutine, which is also known as an arrow. The bottom line is, if you need to produce more than one variable or more than one output, you're going to have to use a subroutine or method. If you're going to produce a single number, you can use a function. Yes, for this. Oh, and so this is a function page just like any other function that comes with Excel. Equals the name of the function and the variables it needs. Here are the macros or subroutines. Once you've created it, you run it, not putting equals in the name of the subroutine or macro. You go to this little dialog box. God, where is it? Locate the place. It's not, well, VBA actually is built into PowerPoint too, but we're not going to be using it here. And VBA, sorry, Word for that matter too. They all actually have access to VBA. But the only one where it really makes most sense is Excel. So here's developer. macros. So these will be all the ones that you have created and are available to you in this spreadsheet. Okay. Now, what you will do is it'll follow your rules, but anyway, so that's where you find them. And of course, you can write mini programs both as a macro and as a function. It's like here, for example, this compute sales tax is actually being rewritten as a macro. And by doing so, you can produce more than one output at a time, not just the actual sales tax, but other information as well if it seems necessary. So if we look here, we should find that sales tax macro. There it is. Oh, what is that? I don't even remember what that's supposed to be. Let's run it and see what it does. Huh. I wrote, it was supposed to mean something at one time. I'll look it up later on. Macros. Here we go. All right. So, um, interesting. Let me just see if I can find the code. It doesn't seem to be doing anything. Um, unless, oh, maybe that's zero. Hold on. Yeah, like I said, I should have relabeled these, but that's going to be impossible to find it. There's all kinds of examples in here. Um, yeah, I guess, yeah, we don't have all of that here. I'll go look for it later. See, the thing is, if I just run a macro, I'll never know what it's trying to do unless I can see the code. So I don't know. I can't find it. Hmm. And there's all kinds of fun stuff here, but anyway, so let's just if we had this code in front of us, you'd see that you could just run it and it already contains the purchase price and the tax rate. Otherwise, we'd have to find a way to get that information. So we'd have to tell it what cells to find it in or something like that. Now, it does have this feature, VBA, that is called a message box, where it's basically designed to be a message to the user of this unit. Um, so by calling it message box, it'll pop up like this on your screen. If that's what you're looking for, you can use message box. Now, if you add something like this to your code, what this is telling it to do is say, listen, put the result of the sales tax calculation into cell A1 so we can see what it looks like. Okay. In other words, sometimes it's not enough to have a result. We also want explanations so we can generate as much information as we want and put it on the spreadsheet. But in order to put it where it belongs, we need this command. Comments, we've already discussed comments. You see how there's a possibility there. If this is actually in the VBA code, it would be green right now. Okay, and that tells us that the computer is not reading it. Now, this is where it gets interesting, arrays. VBA has a type built into it called an array, which is basically, um, if it has a single dimension, then it is a vector. If it has two or more dimensions, then it is a matrix. And it can have more than two dimensions, by the way. Besides rows and columns, it can have like other dimensions going on. Although I can't imagine why we need those, but it does have that ability. So, but all of them are called by the generic name array. So the only question is how many dimensions does it have? So think of a vector as a one-dimensional array and a matrix as a two-dimensional array. And then we just tell it first what the dimensions are and then what the elements are in that array. Now, unlike the other cases we're looking at, where if I have an integer, I don't have to bother telling it dim as integer, but here we do need to tell it what's going on. All right. Now that's because it has no storage space. So if you know that you're going to create a vector or a matrix, you have to tell the program, here are its dimensions, 3 by 2, 5 by 1, whatever the case may be. So with an index, so here's an example. Results is an array, which could actually be a row or a column vector with 5 elements, indexed 1 to 5. We're telling VBA that right now, and we're also telling it that it's going to contain integers with this command. So we kill 3 birds with 1 stone here. Okay. So that is a one-dimensional array. Now here's an interesting twist. The index doesn't have to start with 1. Many of calculus, like we're dealing with series and that type of thing, sometimes those series start with 0. And so in a lot of the formulas, if you remember from Calc 2, for infinite series, they start with 0. So here, many programming languages actually don't have that capability. One of them is MATLAB. I know that from experience. So, but here's where it gets even more interesting. It'll actually allow you to have a negative index. So I could actually start this as -1 to 3 or something ridiculous like that, if there's some good reason for it. So that can be extremely helpful in writing code for option pricing models, as it turns out. Not so much the Black-Scholes, but for American options, as we'll see in the next. Soon enough, we'll see that. Not we still have to discuss the Greeks, and actually that we can look at binomial option pricing model, as it's called, which is designed for American options, and we'll see that what you're essentially doing is filling up matrices with your results. And so here's a refer to the individual elements of this array: results 1, results 2, all the way up to results 5. We can start with 0 if we need to. And option base. Now, this is another command that essentially forces you to possibly override yourself. If you want to make sure that none of your arrays starts with anything other than 1, you can put this object base command in there, and then it will stop you from having a base, or sorry, an index of 0 or negative. Yes, and as I said here, here's one of the things that makes it crazy powerful, to the ability to have negative indices. That's something you just do not see very often. Not only that, but you can actually, the dynamic array means that when you start a program, you can say to VBA, listen, this variable is an array or a matrix. I don't know yet how many dimensions I'll have until I've done some calculations. So I'll get back to that. I'll get back to you later on that. So in other words, in the beginning of the program, all you're telling it is that it's a matrix. Let's say it's a 3 by 3 matrix. Or you can even just say it's a matrix. I don't know yet how many dimensions you have. So down the road, I'll be doing some calculations which will tell me what those dimensions are. And at that time, I can tell the program, oh, it's 3 by 3. So in other words, you're not going to see this anywhere else. If you don't know in the beginning of the program what the dimensions are, don't worry about it. But there's a way you have to specify it. And that's this thing called read. So in other words, you start out by saying dim results as integers, which means it knows this is going to be some kind of an array with integers. And then when you're ready later on in the program, you say redim result modified as integer. So now somebody knows, oh, you wanted the index to run from 1 to 5. Beautiful. And then it sets up the storage and everything is fine. But you have to do this. You must tell it. If you don't tell it right up front, now, I don't have to do it this way. I can tell it right up front that this is 1 to 5. But if I don't know, then this is an option that could be very powerful. To have two or more dimensions, although I think it would get very confusing very quickly. But just remember that an array from matrix algebra has one dimension, and a matrix would have 2 dimensions, rows and columns. Okay. EVA functions. Now, here's something you got to be careful about. This is a testament to how old this language really is. One of the quirky things about VBA is that, well, as part of Excel, for some reason, several commands, it has its own small set of commands that are unique to VBA that also exist in Excel. And when that happens, there's no different. For example, log, perfect example. In Excel, the natural log is spelled ln. In VBA, it's spelled log. Don't ask me why, but luckily, this is only true for a handful of commands. There's just a few that are in both VBA and Excel. And when that happens, you're expected to use the VBA spelling. Or there's a way, well, I shouldn't say that there's a way to override that, but if you're using Excel commands that are not in VBA, there's a keyword that you need to use. Application. Okay. So in other words, here's the function geo mean for geometric mean. It does not exist in VBA separately. It's an Excel command. So in order for us to use it in VBA, we have to start with the keyword application dot. Otherwise, it won't know. It'll say, what do you mean geo mean? I don't know this word, because it's only looking in its own libraries. Once you say application dot, it's like, oh, you mean in Excel? Okay, and then it can go find it. So most of the time, the functions you'll be using are actually going to have this application command, application keyword attached to them. Okay? Not always. There's a handful of exceptions, like this log, for example. Here, you're just going to use the actual VBA command. But most of the time, you're going to see application dot. In fact, we might have some examples here. See if I can find one. Now, if not, I've got code that is based on option pricing theory that we can look at for more examples. These are just general examples just to illustrate the language. But I do also have some examples from the earlier part of the course, actually, where I can show you how you would set up, let's say, a program to use the Black-Scholes model. And in fact, our assignments are going to have to be some version of these because we just don't have that much time left. So, in other words, you'll be able to take an existing program and essentially tweak it into something else. Yeah, maybe not, but I'll show you. Like the next time we meet, I'll show you some examples from, let's say, with the Black-Scholes model, and I'll show you how this is done. All right. You're going to see that application keyword a lot. Let's put it that way. And of course, that's the standard mathematical operators. It does have the Boolean operators. Just be aware that just like VBA, like Excel rather, exponentiation is the Shift 6 key, which is the caret Concatenation means combining two pieces of information, which we often see used with string variables. So let's take the variables, first and last name, John Smith. I can combine those into a single first and last name, but I need these ampersands. You've got first name with blank in between the two names, and then again with the last name. Logical Boolean operators, not and or and XOR. You can use those if you want. I find it to be a little confusing, but um, I use them all the time. They're actually, I should say, I use OR all the time. Not and XOR, I think, are very confusing. So this one tells me that X is greater than 100 and Y is less than 100 is equals 0. And that, of course, means only set is equal to 0 if both of these conditions are true. One of them is not good enough. With the OR, I'm doing set equal to 0 if one or the other are both true. And then here, now this is why I don't use this thing, XOR, exclusive OR. Well, this will be set equal to 0 if X, if this is true, or this is true. Not both. That's interesting. It must be, I'm sure there's going to be times when you might need that, but you've got to be so careful with it. All right. Now, not, of course, means the opposite of what not X greater than 100 means X is less than or equal to 100. It would probably be just as simple to write it like that, but sometimes it could come in handy. Then we have text functions. I'll leave these here for you to read later on. We don't need these for our class. Oh, we've already seen this one. Oh, here's the quote for lowercase. Okay, so that's, let's see, is there anything else we need to know? Oh, control statements. All right, here we go. These are really important. So you know what, since we've already gotten past an hour, this is so important. I don't want to breeze through this. What I'd like to do is pick it up next time with these. These are called control statements or control structures, and they determine how many times a command will be repeated if ever it'll be executed in the first place. So these we have to really understand. So I'd like to stop here and finish tomorrow with this, and then we'll look at some examples of code for what we've been doing in the class, and then we can get back to the new material. We want to quickly look at the Greeks, and then we can start trying to understand the so-called binomial option pricing model, which is used to price American style options. Okay, and then at the end, we're going to look at Monte Carlo simulation quickly. We're not going to go too deeply into it. We just want to introduce the idea so you can see how simulation can actually be used to price options, as long as we're willing to live with all the assumptions that we're making. Okay, so we'll stop here and we'll pick it up next time with our look at control statements, and then we'll get back to the new content. Okay, so I'll see you then.